All right, the second part of today's lesson is how to do combinations. Now, combinations are almost the same thing as permutations. The only difference is that in a combination, the order of the arrangement does not matter. In a permutation, the order matters. But in a combination, A coming first and then B is the same as B coming first and then A. So we did a problem in the last section where we had to put the letters of July in different permutations. Combinations, there's only one. It doesn't matter if the order didn't matter, then J-U-L-Y is the same thing as U-L-Y-J. That's called a combination. The order of the objects doesn't matter. A and B is the same as BA. So on your calculator, we're going to do these the same way that we did NPR, but instead of an NPR button, you're going to use the button that says NCR. All right? So you find it in the same place. If you're using the black calculator, you use that exclamation point with the NCR and the NPR. If you're using the white calculator, you have to hit the probability button, PRB, first, and then one of your choices will be NCR. I think it's the second choice. So in this problem that it gives me, it says count the possible combinations of two letters chosen from the list A, B, C, D. So when I look at this problem, I'm using combination. So instead of a P, I'm going to use the letter C. And the first number I need is how many total letters are there? Well, there's A, B, C, D. So there's 4 total letters, and I'm only choosing 2 of them. So that's going to be my R. That comes after the C. So on my calculator, I would put 4, and then I would find that NCR button, and then I would put a 2 and hit enter. And again, I haven't done this one yet. Let's do it really quick. 4, NCR, 2. So there's 6 different combinations. There's 6 different ways that you could combine 2 of those letters. And again, that's different than permutations because A and C is the same thing as CA. In a permutation, those are different, but in a combination, we don't care. That's the same combination of numbers or letters. They're just in a different order, okay? So count, another letter problem. You know what? I don't want to do this one. Let's do, what other examples does it give us? You order a sandwich. Let's make up our own. I don't want to do another letter one. So let's say that I've got 10 players on my basketball team. I've got 10 players, and I want to know how many possible combinations of starters I could have. So if you don't know basketball, if you have 10 players on your team, only 5 of them can be on the court at the same time. So if I have 10 players, I want to know how many different starting lineups could I have? How many different combinations of 5 players could I get? And because the order doesn't matter, it doesn't matter if I pick Peter first or if I pick James first. They're both in the same group of people, right? So combinations, it's going to be a C problem, and I'm picking out of 10 players, and I'm choosing 5 starters. So if I plug that in my calculator, 10 NCR 5, I get 252 different starting lineups that I could get, okay? If I had done permutations, that's going to be a lot bigger. But just with 10 players, there's 252 different starting lineups that you could come up with, which you think about a coach trying to pick what players are going to start the game. That's a lot of different combinations for them to sort through, and hopefully their players are skilled enough that they know which 5 and they don't have to randomly choose, right? So there's an example in the book. Again, we're not going to worry about the formulas. We're not going to worry about the formulas. We're going to worry about that button right there in your calculator, okay? As long as you can find that button, you can solve the combinations. So let's look at the next one. You order a sandwich at a restaurant. You can choose 2 side dishes from a list of 8. How many combinations of side dishes are possible? Now, this homework is nice because a lot of times it uses the word combination or permutation, so you know if the order matters. Sometimes you have to think through. So if I'm picking what sides I want to go with my meal, and I've got 8 choices, and I don't know what the choices are, but let's say that I pick French fries and a salad as my 2 sides. If I were to pick it in the other order, a salad and a fry, I'm still getting the same 2 sides. So the order that I pick them doesn't matter because I still get both of them. So this would be a combination. So it's a problem using the letter C in my calculator. Now I'm choosing from a list of 8 total choices. So 8 goes on this side, and I'm only picking 2. So 2 is going to go on this side. So in my calculator, I would put the 8 first, and then I would find my NCR button, and then I would pick the letter 2. And if I plug that in, 8 NCR2, sorry, I didn't have the answers ready for you. There are 28 different combinations that you could pick. Permutations, if the order mattered, that would be a lot higher number. In this case, the order doesn't matter, so we use the NCR button, all right? Okay, homework. That's it, guys. That's the entire chapter or section, I guess, 5.5. You've just got to know the difference between does the order matter and does the order not. Again, the homework usually will tell you, but sometimes you've got to use common sense or some of your own strategy to decide if you think the order matters or not. So 5.5, last couple of problems, 21 through 33, only do the odd numbers, don't do all of them. And then do 34 and 37 through 41, I want you to do all of those, not just the odd problems.